Hello. I am pleased to welcome everyone to the fourth lesson of the course on the module Mechanica. In this lesson, we will cover such commands for drafting engineering documentation as indicating the base of a part, setting tolerances for form and location, assigning tolerances for size, indicating surface texture, and creating breaks in the drawing. For better understanding of the material, I recommend following the demonstrated steps along with me. Feel free to pause the video if you need more time. First, what we should start with is indicating bases on our drawing. Why is this so important, and what is it exactly? There are design, technological, and measurement bases. Currently, we are interested in design bases. These are surfaces, lines, or points of a part, which determine its position relative to other parts in an assembly drawing. For symmetrical parts, the axis of rotation is also used as a base. The command for indicating bases is located in the Symbols group. Click on its icon and select the left end of the shaft axis as the point, using the endpoint snap. Choose the position of the base indication in the graphical space and fix it by pressing Enter or clicking the left mouse button. To edit the created base, double-click on it, and in the Open Base Parameters window, disable the automatic sorting, after which the designation box becomes active. Change the designation to the letter D and press OK. As you might guess, the auto-sorting switch controls the automatic sorting of bases. When it's enabled, base designations are placed alphabetically, considering previously used alphabetical designations of views, sections, and cuts. After placing the base, we can assign form tolerances to our part. Why are they needed? In modern manufacturing, every part is made with a certain accuracy. To define the permitted manufacturing error, form tolerances are introduced. These parameters are indicated on the drawing using a tolerance field and a base, as dimensional deviations must be calculated from a base point or surface. For convenience, enable the ortho mode in the status line or by pressing the hotkey F8. Select the Feature Control Frame command. First, select the surface to which we want to set the tolerance. When selecting the base surface, the graphical element highlights in green. Let's select the left section of the shaft and specify the next point to anchor the tolerance sign line. Place the tolerance sign below. To undo the actions performed, use the Undo command from the context menu or the same command in the command line. To finish setting the location, press the Enter key or select Enter from the drop-down right-click menu. In the first field of the open window, set the coaxiality tolerance, and in the next, specify the deviation amount. We can either set it manually or take it from the standard values, which can be selected by right-clicking in the field. In the standard values list, select 0.01. In the third field, we specify the base from which the indicated deviation will be measured. Click on the third field and choose the Specify Base icon. Then click the left mouse button on our created base D and close the window by pressing OK. We will set additional callouts for the first, fourth, and fifth sections of the shaft. For this, we edit the tolerance designation. Double-click to open the editing window and select the Set Additional Base icon. Place and connect 3 additional callouts to the tolerance sign. Close the editing window by pressing OK. Change the display style of the callout ends. For this, select the tolerance and click on the triangular marker next to the end of the callout. In the pop-up menu, set the type to Arrow. The next step is to indicate surface roughness using the command Surface Texture. Roughness is used to denote the quality of a part's surface and set specific requirements for its processing. Click on the Surface Texture command and specify the roughness for the 40 mm diameter on the left end of the shaft. Bring the cursor to the callout line and right-click on it. In the window that appears, call the context menu by right-clicking in the field below the shelf and select the roughness value, roughness average 2.5. Surface roughness is measured in micrometers, in thousandths of a millimeter, and can be evaluated by roughness average or roughness depth, where roughness depth is the profile unevenness height for 10 points, and roughness average is the average arithmetic profile deviation. Accordingly, the smaller the roughness, the better the part's surface and the more difficult it is to achieve. If we want to continue creating roughness with the parameters of the current one, then activate the Set Next checkbox and then press OK. In this way, we can quickly set the necessary number of roughness symbols. To change the position of the roughness, click on it with the left mouse button and drag the attachment point to the callout line. If necessary, flip the icon by clicking on the arrow next to the attachment point. If the part is large and does not fit on the drawing, but has extended sections with the same geometry, it is recommended to use a conventional break symbol on the drawing. To denote breaks, we will use the command from the Utilities group. Activate the command and specify the first point of the break line. After that, we can change the type of the created break or gap in the command line or context menu, which can be called by right-clicking. Select the to-curved break. Specify the endpoint of the break. By moving the cursor to the right or left, we determine in which direction the break will be created. Its width can be set either manually or by entering the desired value in the command line. Move the cursor to the right and enter a break width of 2 mm from the keyboard. Press Enter. Repeat the creation of the break on the 5th section of the shaft. In addition to location tolerances, there are also size tolerances. That is the difference between the minimum and maximum permissible size value. Let's set up such a size tolerance. Double-click on the 51 mm diameter dimension of the 3rd shaft section to enter the editing window. Change the method of recording tolerances to letter designations. Finish editing by pressing OK. We will set the same tolerance for the dimension on the 5th section. To assign a tolerance to a dimension, we'll enter Dimension Editing and press the Fit Table button. In the window that opens, switch to the Shaft tab and set the tolerance value to K6. Press OK. To change the tolerance on the 5th section, we will use the Property Copying function. Double-click to start editing the dimension, and in the opened window press the Match Properties button. Select the previously edited dimension, and for the 40 mm diameter dimension, properties will automatically be set as for the specified dimension, tolerance K6, and the method of recording tolerance. Confirm the changes by pressing OK and see the final appearance of the shaft with the presented base, roughness, breaks, dimensions, and tolerances. This concludes the 4th lesson, dedicated to various commands for formatting engineering documentation, comes to an end. Thank you for your attention. When you're ready, move on to the next lesson.